Welcome, everyone. My name is Michael Gibbs. I'm super excited to be here with you today. I'm actually here with a good friend of mine, Imran, and today we're going to talk about networking. We're going to talk about the networking's past, networking's present, and networking's future. And we're going to also talk about all this cool networking things and how that actually pertains to the cloud. And the reason we're going to do this and it's so important to us is everything that we're going to really be dealing with requires the network. So after working in networking for decades, what I can tell you is if you don't have a good network, you don't have anything. So that's why, we're here to talk about this. Let me tell you a little bit about myself and let me tell you a little bit about Imran, who I am so honored to have on this call today. For those of you that don't know me, my name is Michael Gibbs, and I've been working in this tech field now for well over 25 years. And during this time, I've had the opportunity to work in networking, I've had the opportunity to work in security, and I've had to work in cloud computing. Now, I also have Imran here, and Imran has been involved in tech for about as long as me. And he's worked at all the great tech companies, Cisco Systems, Juniper Networks. Imran is one of those guys that, realistically speaking, has built and done some things that are on the bleeding edge for decades now. When the architects at Cisco like me would design it, people like Imran would actually build it. And not only would they build it, they'd even be there to ensure that our designs actually worked properly. So if I would design it, someone with his skill would be doing the proof of concept, and he's got a wealth of knowledge. And in addition to this wealth of knowledge, he's just such a fantastic guy. He has 2 CCIEs, which I find, to be pretty amazing. Because I can tell you, when I took the CCIE exam back in 2000, it was this miserable 2-day exam where the first day they ask you to build something, which basically nobody could do. It had an 80% failure rate on the first day. And then the second day, what happened is they'd ask you to rebuild it. And then after that, they'd make you go to lunch and they would literally break it. So those were those fun days. So he's done it twice. And not only has he done it twice, he's around my age and he's saying, I'm doing a 3rd CCIE. And I say, why are you doing a 3rd CCIE? And he says, I want my son to become one. So to prove it's possible anywhere, anytime, I'm going to do it. So when I hear things like that, that just blows me away. So Imran, I'm just so excited to have you here. Do you want to say a few words about yourself?
Thank you, Mike. Thank you, Mike, for inviting me this excellent event. Really appreciate it. I'm honored to be the part of this team. I'm honored to be the part of working with you, working with your customer, our customer, to move this journey. What I started and you started 25 years ago, from basic networking when we started in 90s, early 90s. So I'm happy to be part of this journey, and we'll be talking to the audience how this journey becomes towards the transformation to the new cloud. So.
Thank you, Imran, and welcome again. I'm just super honored and privileged to have you here. And, some people in the community are going to see some pretty great things coming from us in the future with regards to network architecture and cloud network architecture training. So super happy to have you here. I want to begin with, the old school network and the cloud before the cloud. So I can tell you that the first cloud I worked with was Frame Relay. How about you, Imran?
Yeah, same. My first job, it was configuring the frame relay and ISDN network. So what is the difference? How do we transform this old technology to the new cloud era?
Absolutely. And Craig, we're going to get to your question very soon, but we're going to lay out the fundamentals. So Craig, we're looking forward to talking to you about the cloud network with the data center network, the similarities and the differences. And trust me, they're a lot more similar than you would imagine. So the next cloud that I worked on was ATM. So in Frame Relay, we're pushing frames. And for those of you guys that have not been in networking for too long, what happened is there was this cloud. And what the cloud was a series of phone switches. And basically what happened is you would provision a logical circuit through it. Kind of like a VPN, but it was layer 2. And that was the first VPN, which was also the first cloud. Now that went from frames to all of a sudden we had high performance cloud computing, which was ATM, which was basically an optical interface. And now we were passing 53-byte cells instead of frames. Was that your next one?
Absolutely. Same, Mike. Same journey. The technology evolved from frame relay to MPLS, and even if we go further, X25 and move forward. So the transformation is the same, absolutely what you just described.
And I'm going to introduce how we got to certain concepts, and we're going to go through all the networking things. But I want to talk about the lessons we learned from network design as well. But we're going to get there when we had 10 megahertz CPUs in our routers, and how that implicated how you build really high availability, high performance. But let's go to the next evolution. There was this concept, there was RFC 2547 or a BGP VPN. And basically what was happening is we had these virtual routing and forwarding instances, and we put it into multi-protocol BGP, and we would pass individual customers routes. So now we have the first layer 3 VPN. I loved it, Imran, because I was Mr. BGP. I did nothing other than BGP and multicast for basically a decade. But when we tried to talk to people about, here's what you do, you're going to run multi-protocol BGP to the customer, and you're going to put your stuff in a VRF. For me, when I had these conversations with people, they're like, Mike, this sounds fun to a BGP geek like you, but this sounds kind of complicated. Did you work with a lot of those?
Yeah, I worked a lot of BGP, route reflectors, federation, all kind of technology. Those technologies still exist with a different buzz name now a transit gateway and a cloud computing perspective. Yeah. So the technologies are there evolving. There's nothing much change aside from the new GUI interface for SDN or SDA kind of a thing. But on the back end, if you're talking about SD-WAN, the technology, the OMP protocol we are running, which is a drive from the BGP. So
exactly, it's all BGP. And when we discuss cloud networking and we start talking about things like Imran mentioned, like route reflectors to combat non-transitive routing, you're going to see that 25, 30 years ago, we were using Cloud Hub equivalent or transit gateway equivalents, and all this stuff came from there. And that's why for people like Imran or me, when we moved to the cloud, it was like, okay, we've done this for the last 25 years. Nothing's really changed for us. So I got to say, the next cloud, I resisted. I absolutely hated this cloud. So I worked for a company called Riverstone Networks, which was the old Cabletron, and it now is the Nokia. And I worked for some engineers and architects at this organization that were just brilliant. And I went in there and I was used to these BGP VPNs over MPLS, and I loved them. They were simple to me. And now the concept was, what if we could start bridging all this layer 2 stuff over an IP network? And I was thinking, oh, great. I've just spent the last 5 years of my life ripping out switch networks and VLANs and spanning tree and all this other nonsense to go to layer 3 networks now that we have layer 3 switches that are fast. And okay, wait, now we're back to layer 2 and spanning tree. I was like, oh, this is the stuff that I hated and worked so hard to get rid of. And then it became the new standard, and I was there, and Luca Martini over at Juniper Networks had that Martini draft that was pushing the layer 2 stuff over MPLS. My company, Riverstone, was one of the people that was kind of founding this VPLS thing, and guess what? That's what we're all using today. For the most part, these Ethernet over MPLSs, all came from that generation.
Absolutely.
And even when you connect to AWS and you're sending them an 802.1q tag from a VLAN, they're doing the same thing.
Absolutely. That's what we're doing for the last how many decades? Absolutely.
Yeah, 2 decades now. So
yeah. So there's nothing much change. Absolutely. And I'm seeing a lot of gap because the cloud providers, the MSP service provider, their native construct does not have much networking capabilities, and they are not focused on that. So I think we will talk about it. What is the lagging behind the MSPs, and why we need a networking profession to be the part of the successful cloud architect. Absolutely.
That's really great. I was going to talk a little bit about more history things, but you know what, Imran, you brought up a good point. So why don't we do this? I had promised the audience that every 10 to 15 minutes, we'd answer a few questions and we'll go back on topic. So let's do that. So let's answer a few questions and go back on topic. The first question is from Chirag Nair. And what does a person need to learn about cloud networking? Well, we're going to talk more about that here, but let me give you a brief overview, and then I'm going to ask Imran his perspective. When you're dealing with the cloud, you're dealing with a subset of the networking things that we used to do on the surface. Now, and the reason I say on the surface is as follows. We still have to do all the same stuff. And the problem is this networking knowledge that we're actually talking about to do these things is limited to a small number of people in the networking world. And like I said, in my world, what happened, most of the networks that I've fixed in my entire life were designed by highly intelligent, non-networking people. Now, what do I mean by that? You'd go into an organization, they'd have a Linux admin that was a super smart guy, genius, actually. Then all of a sudden it's like, hey, guess what? You're now setting up and designing the routers. But they weren't routing and switching architects. So what would happen is they were smart enough to figure out how to configure these things, but they didn't know how to design these things. And, that's what happened is we'd start getting outages, EIGRP stuck in active states and all these kind of things. And you know what's happening now in the cloud, Imran? We've got PC people and software people that don't know the network. And you know what happens when they design stuff on the cloud? It breaks. Are you seeing the same thing?
Absolutely, absolutely. The first part of the cloud is you're creating VPC, and VPC is all about networking your CIDR block, your subnets, your routing table, your NAT gateways. If you don't design it properly, your network would not scale properly. So absolutely, and you're right. The peoples are not responsible for networking. When you enter the company in a corporate enterprise, you will be surprised they have multiple accounts, multiple VPC already creating by marketing, finance, and different division, and they have no knowledge of how to scale, how do we design better. Absolutely.
And that's why we like to talk about these classical things. So when we talk about cloud networking, and we're going to talk a lot more about it, we're going to be talking about BGP, because when you're connecting to the cloud, it's an external entity. So we use an IGP or interior gateway protocol to optimize our routing inside of our autonomous system, and outside of it we use BGP. So you definitely need to know that. But you know what else, Craig? BGP is one component of it. You need to really understand eBGP and iBGP, because all those iBGP challenges are interior BGP challenges, such as non-transitive routing, and they get pretty complicated. Realistically speaking, that stuff, is the basis of all of what goes on in the service provider. And the reason is when you truly understand BGP, you can look at it this way. If I've got Imran to the left of me, and I've got my wife to the right of me, and we're all separate entities. If Imran tells me his routes, pushes them to me, and I tell them to my wife will now transit through me to reach Imran, and Imran will now transit through my wife, which is perfect because I want them to talk to each other. But if I didn't want them to talk to each other, I could then become transit to half of the internet, or I could be providing transit to half of the cloud. So when you're dealing with the cloud providers, what they're really doing in many of these cases is they're limiting your ability to actually cause yourself trouble, because they know most people aren't network people. But there are times where you have to do this. So in iBGP, for example, we break the non-transitive routing due to scalability reasons with something called a route reflector. What is a route reflector? It breaks the rules of non-transitive routing. I learn a route from Imran, I pass it on to my wife. She can now come through me to go talk to Imran, but I desired that. So you definitely need to know BGP, and not just BGP and iBGP, you need to know that algorithm. Prefer the most specific route. If the next hop is not available, don't put it in the routing table. Choose the path with the largest weight. Choose the path with the largest local preference. Choose the path with the shortest AF path. Use the lowest med. So those kind of things you're definitely going to need to know there, Craig. Now, what else are you going to need to know? You've got to know NAT in depth, because NAT is not just to connect to the internet. NAT is used anytime you've got overlapping IP addresses. So what happens when an organization connects to 1,000 other VPCs? For the most part, everybody's using the same IP addresses, that RFC 1918 private address space, meaning the 10/8, the 172.16/20, and the 192.168.0.0. So we've covered, and Imran, please, in a minute, I'm going to finish. I'm going to ask you what I'm forgetting, because we're just doing this on the spot. So we're talking about NAT. We're talking about BGP in depth. Now, you also need to have a really good concept of switching and virtual LANs, so VLANs. And because you're going to be using trunking when you're going to the cloud provider, you must understand 802.1q tagging, Q and Q tagging, Ethernet technologies, as well as Ethernet over MPLS, how it is, what it works, and it would also be good to make sure you have a good, strong understanding of DNS, though I don't consider that networking, the way Ethernet works and ARP and things like that. You probably should have a good knowledge about how to use protocol analyzers or sniffers, especially since sometimes you need to debug things. You can't find your data where it's going. You should have good knowledge of Cisco NetFlow, because you can see things on your routers, but you can also look at VPC flow logs, which is a lot like NetFlow on the cloud. So we're talking a lot about, you probably also need to understand network security as well. Meaning if you're connecting your data center to the cloud, not all subnets need to reach the cloud. So you should be limiting routing information to subnets that need to be there. Now, also speaking, you should be protecting your cloud. Let's say you've got a NOC or a network operations center that's sitting in your building and you're connecting to the cloud. What if one person's PC gets infected with a worm? It could literally fill up your direct connections. So you really need to understand QoS policies. You need to understand how to lock down systems, private VLANs, 802.1x authentication, any kind of AAA authentication, authorization, accounting, which is also kind of also referred to as IAM. Then you need to understand all kinds of policy makings when you're peering to external organizations. You must have a deep understanding of private lines, how they work, a deep understanding of VPN technologies, so a deep understanding of IPsec, a good understanding of SSL and TLS. I don't consider load balancers to be networking because they're not really networking things, but if you would consider them, got to have a good knowledge of load balancers and such. And realistically speaking, networking is so important that I have a lot of my cloud architects focus on a CCNP or a minimum CCNA, and a lot of times a CCNP to go along with, say, a Google Professional Cloud Architect or an AWS Solutions Architect Professional. I'll tell you this, the AWS Advanced Networking, and it's fun, it's kind of like an intro to junior level networking, and it doesn't cover anything close to the kind of networking that's really known. We like it. It's a very good intro to networking and intro to cloud networking, but you need something deeper. Imran, what other skills from networking do you see very important on the cloud?
Yeah, I think you cover most of them, Mike, but I think the wearing a architect hat is very important. Not only learning the engineer mindset, implementing operation troubleshooting, make decision, and doing CLI is not enough. I think what you're teaching, the architect mindsets are, how do we architect? What is the end scale of a network design? What is the understanding principle of different technologies? Not only implementing these technology, how do we architect this? Where to deploy these technology, why, and it's all vendor agnostics basically. So I think what is the key thing is in your architect, in our architect program, is not product specific. It's not about the data sheets. It's about how and where to deploy what technologies based on the different business criteria, the failure domains, how do you resilience, convergence, virtualization, tunneling, what to use, what to not use. So these are the basic design principle we need to into consideration while learning with the technology. So,
you know what, I'm going to pick up on that, Imran, because it's so critical what you just said. Last night, someone sent me an email and then said, why don't you just make an AWS solution design on YouTube? And I said, because I train cloud architects. And what Imran said, I want to really key in on. As an architect, whether you're a network architect, and you're going to see a network architect, how to become a network architect course and get your first network architect job coming from us really soon, as well as how to become a cloud architect on the network coming from us very soon, a collaboration between Imran and I, and I'm excited to do it. But architecture is not implementation. So I want you to look at it from a building perspective. And after we get the building perspective, we're going to talk about the networking perspective. For some reason, there's been some miscommunication in the industry and people think architects are like programmers or configurers, and that's not it. So what Imran said is so true. If I need to design an architecture and I know that I need 20,000 remote locations, and I know that I need a certain level of performance from going from location A to location B, I design that. I look at my network and I say, okay, where do I need the high performance routing? What's going to connect this? And I'm going to build the core. This core is going to be built with the biggest, most powerful kind of routers I can with the most efficient, fastest routing protocol. And then I'm going to work my out to a distribution layer and an access layer. I'm going to think about the services I need to offer on this network. I'm going to see what the applications require, what the latencies are required, how much throughput is required, how much failover and availability is required, how much security is required. That's a design. What's the customer's business goal and how do you do it? Now, what Imran said is so critical. I don't know. I don't pick the name of the boxes when I make a design. That's no reason for that. I know I need certain performances. Let's say out of the network world. Let's go pretend you're just a building architect because the job is the same. If you go meet with a building architect and say, I want a new high rise that's 1,000 meters tall in New York City, that architect says, okay, let me take this back. Let me think about it. Do you have any goals? Any special things at the tower? Any kind of things that you need to do from a marketing and branding perspective? What do you want to make your building special? The architect takes it down. They think about it. They work with the team and they say, okay, building that's 1,000 meters tall. What do we need to do to get the land rights, air rights? Okay, after we do that, what kind of permitting do we need to do? After we're done that, how much strength do I need to have a building that's going to be 1,000 meters tall? What are the prevailing winds? What are the wind gusts? What are the density of the ground? Then they're going to say, okay, we need this, which means we need steel of a certain component. We need wood of a certain component. We need glass of a certain strength. They're going to design it, cement, and then you know what? They're going to hire a construction team to build it. So guess what? That architect is not thinking of, let me buy ABCD brand steel. They're thinking of what steel has a certain strength. So what Imran just said, and it's so critical in the cloud, I don't think of S3. And guess what? I don't think of Cloud Hub. I don't think of any service. I think of this, customers' goals and what technology is going to get them there. And from there, I say, okay, I need object storage. If I'm going to use AWS, I'm going to choose S3. If I'm going to use Microsoft, I'm going to choose Blob. Same thing for databases. I need to know SQL databases and architect. Apache Cassandra run on a compute instance in the cloud, DynamoDB, Google Cloud Bigtable, it doesn't matter. So what Imran said is we design the systems from end to end. And when we design these kind of systems, it's not based on the name of the service. And we don't configure things as architects, we design them, and then we turn them over to a team of really brilliant engineers that knows how to configure them.
I agree, Mike. Absolutely. Just want to add another point here. When we visit enterprise and customer, so they're saying we are limiting to one cloud provider, but when they have multiple clouds, we discover we have a Google, we have Azure, AWS. So architecting, the demand is a huge demand, is architecting of multiple clouds, and how do you transit what is allowed from where, what peering is allowed, what are the application sensitive, what data go to where. So you need to design very carefully, not a single cloud, even the multi-cloud. And I'm seeing a lot of huge gaps on the human resource perspective, which are responsible and understand the enterprise architecture or enterprise networking, which we have it, which we use it front and back. And so there's a skill shortage I'm seeing in the industry, understand the multi-cloud and how to connecting and architecting this kind of multiple clouds.
Totally agree. I don't see single clouds anywhere anymore. I see hybrid clouds, multi-clouds, hybrid clouds plus multi-clouds. So that's where I'm at. You know, Mark Simpson actually asked a question. We'll answer that and we'll go back to the discussion. So Mark actually asked, you know, Ethernet is almost 40 years old. Will it ever be replaced? Look, inevitably, Ethernet will be replaced at some point. And well, actually, you know, if I comically think about Xerox Corporation, this company had the absolute world's best inventions, and they basically gave them all away because someone on their board didn't think they were interesting. First, Xerox invented the mouse, and also the graphical operating system, which they gave to Apple because they didn't think it was a mouse was a valid concept. Then Xerox actually invented Ethernet. And granted, in the time, the Ethernet we're using was this CSMA-CD, you know, coaxial cable connections. But Ethernet became the foundation. And then all of the stuff went from Ethernet to these optical OC3, OC12, OC192 interfaces. And then guess what? We realized that was pretty darn expensive when we could do 10 gig E and now 100 gig E. So I think we're going to have Ethernet for another decade at least. What do you think, Imran?
Absolutely. It's going nowhere. I don't see it's going anywhere.
The reason is it's so cheap and so
Yeah.
effective, and the signaling is so simple. See, simple is elegant. Once we get out of complexity, that's there. So I like to keep things really simple. So, Mark, I think we're going to have it for a lot longer. So let's talk about what actually went on. And then as we talk about network technologies, let's talk about how they turned into the cloud. So what enables the cloud? Virtualization. That's it. The cloud is just a virtual network and a virtual data center. How old is virtualization? So the first virtualization things that I worked with were something called VLANs or virtual LANs. Basically, we would take a switch and we would just chop it into multiple switches. And let's say 100 ports on a switch. And you'd say, these 10 are now one logical switch. These other 10 are another one. These 10 are another one. And that was virtualization. And then maybe 5-10 years later, VMware, funded partially by Cisco and a few other companies, now started virtualization of the servers. Is it really any different?
No, not at all. If you start from VLAN, when we start configuring the VLAN, the concept is there for a long time. Absolutely. Awesome. I think you described the best example where the virtualization started from VLAN. The segmentation started from VLAN. Yes, absolutely.
And then let's take the VLAN. Let's take this concept of private VLANs, which came out around circa 2002. For everybody, you know what a private VLAN was? Normally speaking, in a VLAN, everybody in that VLAN or same subnet could talk to each other. Then all of a sudden, we realized that maybe we could use more security. Maybe we could put everybody in the same subnet, but not let them talk to each other. Now let's think of the future of cloud computing. How could you put multiple isolated things on a single operating system and segregate them? Now that's called a container. So that's why, a lot of the networking people that I've worked with over the years found themselves as senior and principal cloud architects with no cloud training whatsoever, no cloud certifications, nothing, because people knew them and they're like, well, you've been a cloud architect for the last 3 decades.
Absolutely. Cloud is nothing, just another data center. And you're renting that data center. And of course, whatever the advantages of the cloud, agility, another thing, but the stuff is the same. It's a different GUI only, but the main function, of course, the same, the routing function, the control function, data.
It's the same thing. And one of the reasons we're bringing this up and we're talking about how it's not new is the following reasons. People ask me every day, how do I learn the service? How do I stay current? And I say the key to this is having extremely strong fundamentals. When you know what this is at the level that it's normal, the next time you go to the new AWS press release or the new GCP press release, you're going to go say, I know that this is 3% different. So when people ask, Mike, how do you stay current? Well, first, I keep really smart people like Imran around very close to me that I can always ask questions to. I also used to run a business council of CEOs and CIOs when I was at Cisco, and they would tell us everything that's hired 5 and 10 years from now. So that was there. And I also have a lot of executives that I speak to every day at these big tech companies. But most importantly, it's the same stuff. This stuff that we're using came out in the 1970s and 80s, some of it even, and the 90s. So it's just tuned just a little bit. So when you get good fundamentals, you will always, always, always be current. So let's look at what happened. All of a sudden, virtual switches, virtual containers. We went from, when I started, a 56K lease line between New York and say Delhi was about $5,000 a month, 56K. And then out of nowhere, we've got basically, you can get a 10 gig connection to the Ethernet, 10 gig internet connection via Ethernet for about $800 a month. Now, private lines may be 5 times more of that, but now you can get, a 10 gig connection for a few $1,000s per month to location. So next thing is, like, now we've got high performance networking. Do we need to store all this stuff in our data center, or can we aggregate it somewhere else, maybe where there's cheaper electric and things? So the first generation of the cloud was this. Go set up a data center in the middle of Kansas, like a place like McPherson, Kansas, where they have 5.6 cents per kilowatt hour electric. And you put them all in those places and you can remote manage them, put them there. The next evolution is like, hosting providers like Rackspace. And Rackspace, you basically put your servers there or you'd rent their servers. They even developed their own virtualization hypervisor, and poof, next thing you realize, that's a cloud. And then when I was at Cisco, my team, all these big cloud providers were like, wait, all these other companies are making so much money at hosting. Wow, what could we do? Now think about this strategically from a company like Amazon. First, they built this massive global network to sell their products. Now, massive global network. Now, what can they do? They can keep their global network on still the most best up-to-date things. And then they could have taken their other stuff that was maybe 2 years old, and all of a sudden they can use that and resell those services on the cloud on those servers because those servers are still good. And until recently, very recently, like the last year or so, last time I checked, Amazon was using these E5 2670, 2678 B3 CPUs in many of their machines. Guess what? They just replaced them. I have a data center full of Amazon's old servers. They are absolutely fantastic. I use them all the time in my own labs as well as for my students. So I've got a full data center of these things because I manage my own cloud. But the cloud's just what we've done forever. So please kind of get that. So now that we're here, now let's talk about some of the challenges that we had initially and how if you learn from those challenges, you're going to be the best cloud network architect. So when you're dealing with the cloud, you're very limited in your routing. If Imran creates, a connection to the internet with 5 internet service providers, and he wants to load share, he has to run BGP. So Imran's going to take it on his router, which he's going to set up about 800,000 routes from each one of those service providers. So you got that 5 ISP connections, you're taking in about 4 million routes, and then you're going to figure out which is the best path, at least in your routing information base. Now, let's say you want to connect to AWS. They limit you to 100 routes. 100 routes is nothing. I mean, how many enterprise networks have you worked on, Imran, that had more than 50,000 routes on the routing table?
Certainly, too many.
Yeah, too many. Now, what happened was, and I want you to understand, where we came from, Imran and I. So Imran and I came from a world with a CPU, like a 25, a Cisco 2500, was about 25 megahertz, and it had 16 megs of RAM in it.
Yep. So
Imran and I came from that. And I remember when Cisco invented the best, fastest gigabit switch router. This thing was like $200,000. It was super high availability, and it had a massive CPU. It had a 200 megahertz CPU in it, and it had like 64 megs of RAM. This was massively powerful. So what are the lessons from this? Do you know what happens when you take in 5,000 routes into one of these big switches and then a link breaks? What would happen is the routers would have to recalculate the paths. And what would happen is as these routers would recalculate the paths, their 25 megahertz CPU couldn't handle it. So they'd run out of CPU performance. They'd be trying to recalculate these routes, and the router would crash, either reboot or freeze. Or what would happen is it would do this, all the routes would get lost. They could become stuck inactive or something like this. And then you'd have to really remediate and troubleshoot your network. It'd be going up and down, up and down, up and down. So what did we do, Imran? We did something, I did route summarization and a few other things. What kind of tuning did you do?
Absolutely. Route summarization is the key to minimize the routes. Absolutely. And you just said we need to have a basic fundamental or strong, and that's need to be used what you used to do a CCNA level kind of a thing, or maybe a CCNP level kind of a thing. That your fundamental need to be strong. It doesn't matter what cloud you're in, and there are some limitation on the cloud's native construct. So that's why you're right. Absolutely.
So the reason I want to bring this up, and I'm going to kick it back to Imran, we couldn't do many routes because we had CPUs that were 25 megahertz. Now, when you're connecting to the cloud, they basically limited you to routing performance, at least with regards to route numbers, that you were back in, say, 1999. So all those design principles that we had to do to be really specific when we had access to, old technology, that's what you have to do now on the cloud. You got to basically have the knowledge to do it 20 years ago. So when we're talking about this, what are those implications? Well, if you can't have too many routes on the routing table, you've got to summarize. Now, what do you need to do from a design perspective in order to be able to summarize your routes, Imran? What has to be done from the design perspective?
I refer back to you,
Okay.
You just describe, Mike? Yes.
Sure.
Of course.
So all of this really comes down to your IP addressing scheme.
Correct.
If your IP addressing scheme is really elegant, let's say you've got 3 locations, and one location uses the 10/8 address space, one uses the 172.16.0.0/16, and one uses the 192.168.0.0/16. You know what you need to do in terms of route? You need to send one route to each one. So now we have 3 organizations, and inside of each organization, what we have specifically is a lot of detail about what's going on. But in between organizations, all we have is basically, come to me for this. So let's really put it into context. Let's say, I wanted to go to Imran's house. He invites me over for dinner. All I need is to know how to get to Imran's house. I don't need to know anything else. I've got one route, one airplane flight. Literally, that's it. I know it. Now, when I get to his house, if I have to go to the bathroom, I'm going to say, Imran, where's the bathroom? If I need to use a computer, I'm going to say, Imran, where's the computer? If I need to get something from the kitchen, I'm going to say, Imran, can I have something from the kitchen? And where is your kitchen? So all I need to know is how to get to Imran's house. And once I'm in Imran's house, he's going to give me more information. So this is the same thing that's done with routing. In these old days, and now the new days, because of the cloud provider's routing limitations, what did we realistically have to do? We had to basically summarize or limit everything. Are we in the same place? We have to summarize and limit everything?
Absolutely. That's what I initially says. When you start in the cloud, you start from your VPC, and VPC start from your CIDR. So you need to plan very efficiently how you do your CIDR. And the other issues with the enterprise, there are always acquisitions. So they are coming with existing CIDR. So how do you NAT those IP addresses? How do you summarize it? You need to plan well. Absolutely. That's the key thing. Your IP addressing is the key thing for your design, for your cloud, rather cloud on-prem, whatever you go. So absolutely, I agree.
Yeah. Just IP addressing. I got to tell you, coming up with an IP addressing scheme and understanding that is substantial. Now, it may sound simple. I can just subnet here. I can supernet here. Look, knowing how to subnet or supernet is easy. Knowing how to look at the things and saying, okay, right now we've got 10,000 employees in this location, 10,000 employees in this location, 30,000 employees in this location. Right now, this location has 500 subnets. This one's got 1,000 servers. This one has 25,000 servers. Knowing the security and performance, that's all design. Knowing to say, okay, if the organization grows, how can we address that? Leaving the appropriate addresses. It means using the right subnets for everything. Realistically speaking, these are those kind of things that are absolutely super essential.
The other key thing is, Mike, as you just described, we have 2,500 routers now. We have more CPUs, more stronger routers, more EC2 or servers, strong CPU servers are available in the cloud. Yeah, more easily. The flexibilities is there. Absolutely.
Yeah, so I mean, that's really, really, really great. So let's take a few more questions because I understand there was, and Pravin, I'm so happy to see you here. Welcome. Fundamentals. Fundamentals of storage, fundamentals of everything. That's how you become a great architect. Charag actually asked a great question. Should a cloud architect need to do a CCN or Juniper search before becoming a networking champ or AWS GCP? So let me tell you how we do it in our program, and then I'll give you some advice on how to do it. In our program, we do them all together. So we have a 250-hour how to become a cloud architect program. And the way we do it is we have 2 live sessions per week. And in these live sessions, we do live architecture training. And in between these kind of large architecture trainings, we use videos. Now, what we do when we're doing this is I get everybody to have deep networking knowledge, because if you have no networking knowledge, you've got nothing when it comes to the cloud. So we focus heavy networking in everything. We also assume that we have to use military-grade security or better in every design. So when you're planning for the hardest challenges, and our students do this every time, our students look at these designs for these big global enterprises on our architecture calls twice a week, and we do the networking. So when people say, should I learn networking first or after? I say do it at the same time. So a long, long, long time ago, I was practicing internal medicine. I was a nurse practitioner. I had my own office and I loved it. And when I went to school, it was as follows. First class was like a physicalist exam class. So I'd be in one class and we'd be examining each other, learning how to do exams. The next class would be a pharmacology class, which is the study of medication. The next class would be a pathology class, the study of disease. And we studied all these things in parallel, not one at a time. They had to be in parallel. And initially, when you take these classes, it's like, oh my God, they're throwing all this stuff at me. It's crazy. But something magical happens. The things from pathology start to click in with the things from your pharmacology class. And that clicks with the assessment class. And then one thing builds and builds and builds on each other. So when we train people, we do deep fundamentals on everything. And when your fundamentals of the network are strong, then your fundamentals of security become pretty easy. It's not that much attacking on. And when your fundamentals on servers and virtualization are good and load balancers, you pretty much know the whole cloud after you learn storage. So I say, learn the network, learn the security all at the same time. Now, what's really needed to be an architect on the network, like a cloud architect, is a little more than CCNA knowledge. See, the CCNA, and I love the CCNA, is basically speaking it's an intro to networking, and it's also how to configure things. Unfortunately, as architects, we don't configure things. We're fortunately, thankfully, because I don't like configuring things. I did it for a while. So you kind of need to cross between the CCNA level knowledge of the switch and the VLAN and how all those things kind of work. And in addition to that kind of knowledge, what you actually need is you need the BGP knowledge of a CCIE, and you need the NAT knowledge and all those other things of a CCNP. So with our students, we've got a custom training program. Because it's so important, Imran and I are going to be releasing a completely new cloud network architect program. And that thing's going to be coming out with at least 250 hours of content and live training on how to become the perfect cloud network architect. We're also going to do a network architect one because I get asked by my friends in networking every day. I've been a network engineer for 2 decades. How do I become an architect? So we focus a lot on the cloud and the network. These are our 2 primary focuses because, we're cloud people, we're networking people, and that's basically all the compute that actually goes on in this world. We're also security people. So I say that's really important. So you've got to learn the network. So CCNA is a really good point. After the CCNA, you've got to understand BGP. So if you're one of our students, look, it's covered. If you're not, you got to read the book, Internet Routing Architectures by Bassam Halabi or Sam Halabi. Read every BGP RFC. If you're with us, we'll make sure you understand NAT, overlap, one-to-many, which is man-to-many, static NAT, all these things. Because as Imran said, when you're buying companies, and companies buy companies all the time, they're using the same IP addresses, literally all of them. And then now you're on the cloud. And what's great about the cloud, which I love, everybody's already connected to the cloud. Literally, everybody's almost there for the most part. So instead of building these private WAN links, you can just create like a private link or a VPC peering environment. So the cloud makes it easier. The problem is the cloud makes it easier. So the benefit is it's easy. The problem is it's easy. So because it's so easy, people literally start teaching these things and doing these things, but they don't even know what they don't know. And that's where all the outages come from. So there's a hack on the day, millions of hacks every day on the cloud. Not because the cloud's not secure. 16% of all cloud hacks are related to misconfigured S3 buckets. So when you make something overly simplified, if you don't know the complexities that's underneath it, that's when disasters happen.
Absolutely, Mike. I think you hit the main point on that. Because the cloud architect has not become the CCNA level thing. Is more than CCNA, and CCNA just give you the fundamental strong knowledge of networking, plus along what we are trying to put this in a program is understanding how do we architect, not only the configure things, how do we architect, how do we scale, what is the scalability, what are the business use case we are trying to solve, because every week call we have this discussion, scenarios, use cases, how different use cases Mike is doing it already with our existing customers and students. This is the use case. We go and build the network based on the use case. So Mike is already doing it. It's a wonderful thing too.
And thanks, Imran. I'll put it into And thank you, Mark, for regarding our BGP YouTube class. We wanted to produce a good intro to BGP. There's also a blog that we produced on it that Chris from my team can actually, that will pop in the chat box to try and help everyone. But it's really interesting. One of the very innovative SDN type network providers recently added a BGP to their firewall appliance. And I was really excited about it because it made it a really great appliance. So I know the people that are the product managers, I've spoken to them, and then out of nowhere, I see a systems engineer post and say, guess what? BGP with a GUI. Now you don't need to know anything about BGP. No longer do you need to spend thousands of hours learning BGP. And I looked at this and I said, well, just because you configure it easy doesn't mean you can tune it easy. I said, how do you not become a transit AOS? How do you manipulate your traffic? And as it turned out, I knew the product manager really well. And I called him and I said, look, it's Mike. And he's like, yeah, great to speak to you, Mike. I said, I just saw a post from someone on your team and it's a well-meaning guy. I said, he's saying you don't need to know BGP now that it's got a GUI. And he's like, what? I said, look, when you've got students and people that work for you that are so motivated, they want to promote it because they're excited. He's like, yeah, I love that. I said, so maybe just help temper down the expectations. I said, because you know it and I know it. Because this is someone that I actually coached and actually trained that's actually working in the senior role. He was like, yeah, I completely get it. He's like, I didn't notice. He's like, thank you. He's like, I'll do for them what you did for me. And then I'll show them the complexities and the design and how it works because we don't want customers getting the wrong idea.
I want to add a point. I'm working with very large enterprise. They do 100% of automation and scripting, and I'm working to help their BGP issues, very large BGP issues, multiple. I don't want to mention anything here, but the key thing is they configure everything, and they migrate from old to legacy, and we are seeing a lot of BGP issues. And nobody knows where this come from, and they're saying we are all 100% automatic. They are configuring, doesn't understand exactly what you just described. I have a very live example of BGP issues, and nobody knows what is it. So I'm planning on that project for one of very large, complex enterprise customer.
Yeah, and for the network engineers here, they get it. But like, for example, I recently saw a certification provider that's never worked in networking in his entire life. And he makes a new post every day about his networking classes and how networking is simple and he can teach you. And I'm like, whoa, here's what I know about networking. When I was a CCIE with 10,000 hours of just BGP experience, I went, oh my God, there's so much about networking that I don't know. When I first became a CCNA, I thought I understood it. Then I became a CCNP. I'm like, I'm starting to get it. Then I became a CCIE and it's like, oh my God, there's a lot more to learn. So what I say about networking, why Imran and I are talking about this, sometimes the more you know, the more you realize how much networking is. So I've been in networking for almost 30 years now, almost 30 years. And you know what I've worked on? I've worked on BGP, MPLS, IP multicast, and voice. Literally those four things. And I don't consider myself to be a voice person. I consider myself to be a BGP person and an MPLS person. So literally speaking, and multicast. Most of the IP video solutions around the world 20 years ago somehow had my name on it. So if you're talking anything from like the Dubai Marina project to all the IPTV things that are going on, I had a hand in the design of those things about 25 years ago. So that's my world. I know those three things. I'm not a switching person at all. I'm not a network automation person at all. I'm not Mr. Voice over IP. I'm not Mr. Wireless. I've never even worked with wireless. So I really want people to understand that networking is so big that you could take Imran and me, 3 CCIEs between us, and he's going to have a 4th one soon because he wants to prove to his son that anybody can do a CCIE. So he's doing it with him just for that. I have more respect for Imran than that than you can imagine, because I got to tell you, I know what those CCI exams were like. And any person that's going to do a 3rd one at my age, just to show his son that it's possible, what a hero of a father. So Imran, kudos to you on that. That's amazing. And I'm sure your son's going to have as great of a networking and cloud computing career as you and I did. And I'm super excited for that.
Thank you, Mike. Appreciate it. So thanks for your comments. But I fully agree. Like these keep repeating. People are asking me, we need to know Python? Definitely we need to know Python, but we are not programmer. We are not DevOps guys. there are DevOps people. If you understand the programming, it's good, but you have a lot to cover in your networking in a cloud space. So,
I mean, so much so. I've never written a Python script in ages. Now, having said that, I'm an architect. If I was a network engineer that was going to be automating things in today's world and playing with API calls, I would learn Python.
absolutely.
But as a systems designer, people come to me for my knowledge of end-to-end systems design. That's why I'm an architect. Now, I had my network engineering days, and boy, those were fun too.
Absolutely. And if you become an architect, you know how to use your resources, how to cross culture or cross teams. I think that's the key thing. What Mike is trying to teach in a very big team environment. That's why we have a call, live calls, use cases, customer. I think that's one of the beauties thing I find it in my program is the live business cases and those business problems turn to a technology. Learn the technology, understand the customer business impact, and I think Mike and we will teach you how to transform and to their customer business goals.
It's all about business goals, and it's also about playing to your strengths. I'll give you an example of playing to your strengths. I was hired, my second networking job was on Wall Street. I was working for one of the largest market makers in the world at the time. The system at one point could process 4 billion trades in a single day. So I helped design this trading system, and boy, was that fun. I mean, it was really fun. Now they hired me as a network architect. So I joined them, and as soon as I joined them, they handed me a box of stuff. And this is the stuff that they had been putting off for the last 2 years that they really wanted to accomplish. So I started designing it. Now, after I started getting the designs, things started working really, really good. And the chief information officer says to me, Mike, how do you feel about scripting? And I said, scripting? He says, yeah, you want to learn scripting? I said, you want me to do scripting? What kind of scripting? And he's like, so basically you can basically take the logs and a syslog server, basically learn how to pipe and grep for things and output it to a file and then get your answers. I said, well, it's up to you. I said, what's a minute of downtime worth to you? And they're like, approximately $300,000 a minute of downtime. I said, prior to me, how much downtime do you have? He's like, 20 minutes a day. I said, okay, so that was $600,000 a day. Now you've got none of it. I've got a lot more work to do on the network. Would you like me to learn scripting, or would you like me to focus on the network? Now, this person was not a CIO for that long. He said, I want you to focus on scripting right now because everything's perfect. He said, I'm going to send you to Site Microsystems in Boston and you're going to learn scripting. And I was like, vacation. Wow, I'm going to get paid to go somewhere. I'm going to have nice dinners. I'm going to learn something that's, probably good on my resume, something I'm never going to use in life, but you know what? I'll have it. So I learned how to write a bash script. I learned how to write an expect TCL script. And, it was really funny. I get back and they're like, oh my God, Mike, we really missed you. We had a whole bunch of things. We don't want to disturb your training. We had about an hour's worth of downtime. And I was like, an hour times $300,000 a minute, like $1.8 million, or was it $18 million? I forgot I did the number. I said, would you like me to go back to networking? Don't do that stuff. Yeah. Okay, thank you. I never, ever, ever at that point even had the opportunity. So when you're really focused on something and you're good at it, be great at something and show them how they need that, not all the other things.
One point I need to add here: you learn the technology, and the certification will be a byproduct. Absolutely.
And we're going to talk about some of these other things, but we've got a question, and I want to answer this question. This question is meant from Thesh. Please tell us about a firewall. Is a cloud firewall good enough? Or no. Okay, so let's look at your options on the cloud. And let's look at the history of where these things come from. So let's look at, say, Checkpoint or Cisco systems, or some of the newer, really innovative competitors like Fortinet or Palo Alto. These people do nothing else other than make firewalls. If you want a router, you go to Cisco or Juniper for the most part. There's other great routers, but Cisco and Juniper have more experience deploying the best end-to-end solutions than any other company that's out there for the most part. And you know what? When you want a firewall, Checkpoint, Cisco, Palo Alto, Fortinet. All these organizations do is make firewalls, IDS systems, IPS systems, end-to-end security design. And they are leagues and leagues and leagues above cloud native services. So let's talk about it from an architecture perspective, how you know which to choose. Let's say, for example, you've got a small to mid-sized business. They want to be on the cloud. And let's say, for example, we're dealing with AWS. Shield for DDoS protection, the cloud, what do you call it? CloudFront content delivery, maybe some WAF as a web application firewall, network ACLs, security groups, take your servers, disable unnecessary services, add a host-based firewall, patch them, that's good enough for the average small to medium-sized business. Now, let's say you're an enterprise. Now you're a big target. What are these WAF and Shield kind of things? Basically pretend you're taking freeware, open source things from the internet and you're tuning it a little bit. Now, I got to tell you, which do you want? 10,000 engineers designing something from Cisco for the last 20 years, or a freeware, open source community thing doing that. So if you're a big organization, you're not going to use any of these cloud native things. You're going to be pulling firewalls from the marketplace, pulling in IDS, IPS systems from the marketplace, heck, even pulling in load balancer from the marketplace. In fact, it's so pervasive that AWS basically came up with something called the Gateway Load Balancer. And what is a Gateway Load Balancer? It's a tool to basically load share between your own stuff that you had to put in the cloud to overcome the weaknesses in the cloud. So Mitesh, realistically speaking, the cloud is only complicated for the following reason. Those services that come with it that are super easy to use aren't going to work for the majority of the clients you have. So you basically can look at the things that you were taught in the program in the name of the service and say, okay, I need the VPC. I'm going to use the direct connection. I need to compute. So whether it's EC2 instances or something like that, that's great. We need containers, whether it's a Kubernetes container or something like that, can you use it in the same place. And then you start looking for external services for some of the bigger things. So right now, you can use AWS Route 53. 9 months ago, Route 53 was totally unusable for any environment that needed high security because it didn't support DNSSEC. So the cloud providers are improving the quality of their services day by day. And there will be a point, I predict some point in the future, 15 to 20 years from now, where those cloud services are going to be equally as good because they're going to have a lot of experience. But for right now, you need networking, you go to Cisco. You need, or Juniper. There's a couple other good networking vendors, but they're my two favorite, the two that you'd see most in service providers and things. Firewalls, you're going to get them from the marketplace, not all the cloud providers. And that's why I say you can't just learn the name of the services and how to configure them. You need to understand all of how it works and what is the business use case. What are you trying to protect? For example, I'm going to spend a whole lot more money trying to protect the critical infrastructure than I will something else. So I kind of hope we answered your question there, Mitesh. And Mark Simpson, yeah, scripting is not my thing. Probably never do it my entire life. And if I never have to do it in my entire life, it's going to be a good thing. The concept of programming is something that just makes my brain hurt. Yes, I've learned how to do it in my youth. I hated it. I have deep respect for the people that actually can do that. But realistically speaking, that's where we're coming from. Now, I'm not sure what's going on with the delay. For example, we had talked about the firewalls, and I actually see the question coming in. So there may be 90 seconds. So Mitesh, we did answer your question. So realistically thinking about this, since you and I come from a world where basically first it was EIGRP, and then it was all OSPF or intermediate systems to intermediate systems. And then we started adding labeling for MPLS. And then we said, wow, guess what? We can traffic engineer. So we use RSVP signaling to make sure we have sufficient bandwidth. We lay our primary and explicit path out. Now we have optimized routing and rapid fill-up. Where do you see routing going?
I think what I'm seeing like routing still there. The key difference I'm seeing in the control plane and the data plane separation with the new technologies, what they're offering, SDN, SD-WAN, SDA kind of a thing. Before we used to have one single router and everything is control plane and data plane was a part of one single router. Now it's the key difference is it's not about the GUI interface or SDA or SD-WAN kind of a technology, is the separation of control plane and data plane. And it's a different virtual machine, either router or VMs. But the control function, the brain of the routing is still there. Absolutely, there's nothing much is going to be just a separation of control plane and data plane. And that's the key difference I'm seeing on the routing perspective.
Okay, interesting, the separation of the control plane and data plane. So let's dissect that for the rest of the world. So, because it really has a tremendous impact on cloud computing as well. So let's talk about what is the control plane and what is the data plane. So typically speaking, when you have a system, the control plane is what makes it work. So for example, in networking, our routing protocols are our control plane. The data plane is the connections, the forwarding that goes on in our systems. So I just want you guys to kind of get a good feel for that control plane versus data plane separation. So when you build a cloud, and all my students build the cloud in our cloud architect career development program, which Chris can put a link to, as well as a coupon. So when all my students build the cloud, the first thing they do is they build the control plane. They set up the hypervisors, they set up the containers, they set up the databases that maintain these structures, and that's the control plane. What's the data plane? The data plane is your compute power, the data plane is your storage. So there's that. So now when Imran talks about the separation of the control plane and the data plane, it's really interesting. So let's dissect that a little bit. So when you separate the control plane, or how the routing is actually occurring versus where the forwarding is, could you talk a little bit more about that control plane?
Yeah, so control plane is the main function of your routing decisions, right? So when you separate it in a different boxes, you still have that's the key function, and that you're separating, and so it's not dependent of your data function what the customers are talking. So I think that there is that's the key thing is your scalability design. How do you design your control plane? That's the main differences.
Okay, no, thank you. So I'll elaborate on that a little bit.
Yeah.
You know, from the control plane, you're using stuff outside the network to, apologies, my phone, I have it on mute, but it keeps ringing anyway. The control plane is really the traffic director. So let's say, normally speaking, it's actually sitting on the network, but it's not on the network anymore. Now it's basically controlled by something else. So imagine this. Imagine you've got this person flying around in an airplane that has a global view of your entire network. And this person's on the airplane, and this person's, super genius that's plugged into everything. And the person says, choose this path. Wait, there's a little congestion on the way. This is the faster path. Oh, wait, let's choose this path. And what's going on is you're getting constant path optimization. So when we talk about internet routing versus private line routing, if I've got a private line connection to Imran's house, and I'm probably going to have to do this at some point based upon, all the files we're going to be turning around. If I buy 10 gigs to Imran, I get 10 gigs. If I know that there's, 5 milliseconds of latency between Imran's house and my house, there's always 5 milliseconds of latency. We can guarantee that. It's a private line, or direct connection in the cloud, whatever you want to call it. Least line. Now you go from that to MPLS, which is a shared network. Now, when you went to MPLS with a shared network, we had a different kind of control plane signaling, label switching, tag switching, RSVP signaling. That was the control plane. Now, when you did this, what was the problem? Still expensive, and it was relatively complex technology. I got to tell you, people like Imran and I probably spent $5,000 to $10,000 on MPLS before we truly understood it in the way we needed to. So then, now let's take that intelligence off the routers and put it somewhere else. We've got big, massive servers now that I've got servers. I've got, literally speaking, in my house, about 300 cores, Xeon cores, and about 1.5 terabytes of RAM just in my home cloud lab. So imagine I'm using that to control my own network. Now we've got servers with a lot more computational power that can literally look and scan everything. And now we might be able to use the internet. Now we might be able to do this and say, okay, use ISP1 is slow, use ISP2, move our traffic to the next ISP. The evolution, I think, at some point, Imran is going to make the internet, which is now best effort, almost as good a performance as a private line. What do you think?
Absolutely, that's we call it application of a routing. We are controlling the routing function where we want to send the traffic, voice traffic, any other traffic. So we have more control on the routing perspective. We are not dependent of service provider once we have the separation and the control plane and data plane, and those can be designed anywhere part of the world. So absolutely.
Okay, so yeah, that fascinates me, but it's just an evolution of the same technologies. So now I typically tell my clients, when you need high performance networking to the cloud, here's the thing: direct connection. If that's not enough, get a second direct connection. If that's not enough, get a third. If that's not enough, get a fourth. Bundle them into a link aggregation group. And when that's not enough, create another link aggregation group across another internet service provider. And you know what? If that's not enough, create another link aggregation group across another service provider and use BGP for load sharing. Now, but you know what? We might just at some point in the future be able to get some 1,000 gig connections to the internet on both sides and use SDN to route it through the internet. Now, what have we done? We've really knocked the cost out of it.
Absolutely. And one of my colleagues says, and without you can move hands without thinking of your brain. So control function is really, really important. Absolutely. So that is your brain. So you're making forwarding decision. You're moving around without thinking of your brain. So that's very important. Absolutely.
Okay, Imran, now I'm bewildered. I mean, I got to look at it from this perspective. I'm the guy that can practice internal medicine, and you came up with the absolute best analogy in the entire world. From now on, I'm going to think of the brain and the spinal cord and the efferent and afferent nerves as the control plane, the neurological system. And I'm going to think of the musculoskeletal system as the data plane. That is the absolute best example I have ever heard in my entire life. So, and GZ, so happy you're here. When you're ready to work with you, we'd love to work with you, give you any kind of help to get you to your career goals. Love getting people to their goals. So welcome, stay as many as you can. We have lots more free sessions coming up real soon. So please stay tuned. So I love that, the separation of the control plane and the data plane. What is a VPC? Is it a logically separated environment created by a control plane software sitting in the cloud provider and the data plane, or is your EC2 instances, which are your virtual machines and your containers? Did it change? Is anything different?
Nothing. It's just different buzzwords, different technology buzzwords. They are the same, of course. And every cloud provider have a different version of that. Absolutely.
So, I come from a couple perspectives. I come from a martial arts world and I come from a medical world. That's really where I'm at. And I learned two things in these environments. When I was young, Bruce Lee was like the main martial arts guy. He invented a system which was actually mixed martial arts. It was his stuff plus a lot of other things. And boy, that was genius. And I remember in my youth being a martial artist, like, okay, look at this new technique I developed. Look at this new one. And then I read his book. And then I started hearing his message. And he said, I do not fear the man that's practiced 10,000 kicks. I fear the man that's done one 10,000 times. And I got to thinking, oh my God. And then I went back and then I started with medicine a couple of years later. I spent 4 years learning stuff just to be prerequisite under a knowledge, just to be able to start learning. And when I was younger, I'm like, why do I need this? Why do I need these silly English classes? I live in America. I don't need to learn English. I already speak English. And then I had another class that was, a sympathetic communication class. And I was like, young. And when you're young, you don't think of these things. I'm like, why do I need to learn how to make unhappy people happy? And then I had to take other classes that were related to learning about different people from different parts of the world. And I was like, young. And I was like, well, this is very interesting, but how does this make me better in healthcare? I couldn't draw the lines. And then I got a little older and I started to say, oh my God, as soon as I got into practice, I went, wow, learning how to communicate to people means they'll give you better information. With better information, I can fix their thing. Maybe there was some science to it. And then it was learning about other culture. And I was like, wow, this culture does not like blood transfusions. This culture does not like this kind of medication. In this kind of culture, this person is the head of the household. In this part of the culture, people do things this way. And then I learned, oh my God, if you understand people, then you can put things in a frame of reference that they understand. And when they don't want to do something that you don't understand, because it's not part of your world, you understand why they feel that way, and you've got empathy. And then you can help them, because we all have backgrounds that are different, and those backgrounds are what makes us special. So then I started to learn about that, okay, the cultural relevant thing. And then I started learning about all these things that were fundamentals. I didn't realize how much I needed them until I actually got into the world. So these fundamental networking things, IP networking, IP addressing, subnetting, supernetting, IGPs, interior gateway routing protocols, exterior gateway routing protocols, access control lists. Remember those things?
Yep.
You know, all of this stuff, MAC address filtering, all those fundamentals, 100% of it is completely relevant in the cloud. Nothing went away. And when I look at cloud computing courses, they don't teach networking. And when I finally do see something like an AWS advanced networking, I look at it and I'm like, what's advanced about this? This is kind of like an intro to an intro to an intro to a CCNA program. Now, we absolutely love running these things free on the internet, like the AWS Advanced Networking. We teach AWS Advanced Networking on our free class. We don't teach AWS Advanced Networking. I mean, we cover the curriculum from a design perspective, but we inject BGP and we talk a lot more about that. And Chris from my team can literally send everybody who put the link to our free AWS Advanced Networking training. Again, not enough to be a cloud network architect, but if you're studying to be a network architect, you're studying to be a cloud architect, combining that with the AWS Certified Solution Architect Professional will make you much better. And all that training is completely free on our channel too. Now, what's going to happen is very soon, you're going to see something from Imran and I, and it's going to be basically, how do you have CCIE level network expertise and CCDE level architecture design and expert level cloud design and put all the pieces together. So whether you're a network engineer that wants to become like an elite level cloud architect from a network perspective, we're going to have that transition plan. Or if you want to become if you're a network engineer and you want to move into these architecture roles, which I find very fun, let me tell you, that's going to be there too. So stay tuned. I expect some pretty exciting things from Imran with my help. Ebenezer, what a great name. What advice do you go from systems administrator to a career in well development? Well, I got to tell you this, Ebenezer, I am not Mr. Software. So I don't want to give you too much guidance here because it's not my area of expertise. But I will say, if you're a systems admin right now, and you're on the Linux side, which would be helpful, because on the Linux side, you're going to get to be, pretty competent with regards to, locking systems down, disabling unnecessary services, patching them. You're pretty familiar probably with Apache and MySQL and all those kind of things, hopefully. From there, then you basically just have to learn the appropriate coding languages. So it's not going to be that complicated of a choice, but realistically speaking, I am not an application person and I am not a development person. Typically speaking, when I coach people, I try to get them out of these careers. Now, when people ask why I try to get people out of these careers, it's as follows. I think if you love programming, you should do it. I am a very different approach to looking at this world. I have spent most of my life either consulting CEOs, designing systems for systems, or doing what's called management consulting, where you meet with an executive and the executive's got a business challenge and you advise that executive exactly how to meet all of their needs. So we try and do that. And realistically speaking, we coach executives how to improve their business. So when I look at people and I try and improve careers, I try and say, what is the best career that I can give someone long-term for the next 20 years? The reason I stay away from software is as follows. And software development is great, but the reason I don't really work it into our people is when you go to college, people learn software development. Now, I'm not going to say it teaches them great, but they all know software development. So all these people graduate college, computer science degrees, all these other degrees, they all know how to code. So when it comes to web development, there's millions and millions and millions and millions of people out there. Why do I care about this? In economics, we have these supply and demand curves. The greater the supply, the lower the price. Well, if there's 1,000,001 programmers, the lower the salary for the programmer, which means it's going to be much harder to get these jobs, but also the salaries are going to be lower. Now, if you love software and you love development, it's still worth it. Like Mark Twain said, make your vacation, your vocation, or your job, and you'll never work a day in your life. So if you love that, go do it. We typically speaking don't focus on software development careers because all we try and do is basically take people in a very select number of careers, those with the most career advancement, those with the highest profession, the highest opportunities and long-term growth strategies. We coach our people. We add the communication skills. We add the executive communication skills, the presidents, the ROI modeling, and that's how we build careers. So I think if you want to learn software development because you love it and you truly love it, Ebenezer, that is an incredibly great thing to do. I'm just informing you going into it. There's a surplus of web developers and there's a shortage of cloud architects and good network architects. So when there's a shortage, you have much faster career escalation and there's less competition. So that's the only thing that I can advise you is if you want to get into software development because you love it, I encourage you to do it. Do what you love. But if you've just heard from other people that it's a great career to be in, I think there's probably better options for you.
I just want to add one point here,
Please.
Mike. The AWS is less than 20 years is having $400 billion company. So I say the market believes that cloud computing has a lot to offer value, has a growth, this experimental future expected to be very high, and as a result to the Microsoft. So, and you can see the successful apps they develop, WhatsApp, Salesforce, Snowflake. The power in the cloud is there, and how do we get the cloud architect to become the network architect and cloud architect? I think that's I'm seeing a lot of growth, specializing in security and specialization in networking architect. Absolutely.
And that's what I see. The other reason I'm getting less and less concerned about these developer roles, machine learning is getting pretty darn good. And machine learning, you basically create an algorithm, and at some point it reprograms itself. I think we're going to get better and better and better. There's automated code writing coming very soon. I think there'll be less need for people to do it. What you're going to need instead is the architects, the application architects, those people that know how to work with like a network or a cloud architect like Imran and I. We're going to design the strategy. Then we're going to basically say we need these kind of applications. We're going to be working with those application architects. Right now, then they're going to send it to application developers to do it. But 10 years from now, can you automate some of that stuff? I think it's going to happen. I think it's, programming is going to change in the near future. So that's why if everything is going cloud and all the money's going there, and right now, as it stands, just a small percentage of all the organizations that could be on the cloud are on them. I mean, very small, like 15, 20%. Within 5 years, it's expected that 25% of the people be on the cloud. I expect it, for the next 20 years, this cloud thing to grow like crazy. Now, I don't expect it to be pure clouds. I expect it all to be hybrid clouds, multi-clouds, hybrid clouds with multi-clouds. I expect all organizations at some point to still keep their data centers and run an OpenStack Ansible cloud or an Nutanix cloud, most likely OpenStack Ansible, even though I love the Nutanix cloud. It is an incredible, unbelievable product. But I see it going there. And I see it going there because, Imran or I could design a system that will literally have about 10 times the performance of anything anybody can get on the cloud. And there are organizations that still need that. But there are most of your applications that don't need that level of performance. Literally don't need that level of performance. And because of that, that's why I kind of like these kind of systems, the hybrid cloud, the multi-cloud.
The other thing is, Mike, we do in our program the SWOT analysis.
Yes.
The strength and weakness. So based on that, it's one of the initial assignment. Based on that, we advise guys what to track and how to follow, what are the things you need to follow.
Absolutely. And I use a SWOT analysis with all my students in their career. In management consulting, we use a SWOT analysis. So absolutely. So, there's two questions coming in. I'm going to answer one of them, and then I'm going to have, and you can and ask for your input. Then the next question is more on SDN, network function virtualization. I'm going to push that one over to you, Imran, since you've been working with a lot more of that than I have. The question is, Cool Dude 55699, will architecture be automated by AI? I don't think so, and here's why. Architecture is truly as follows. You've got to get in front of that customer and you got to know exactly what they want. You got to be able to have this level of executive conversation and say, okay, what is your revenue targets? What are your pain points? Did you do any research that if you have higher touch with your customers, where can it do it? What's going on with your vision? What's your future vision? What's your future strategy? What are your goals? That takes humans. And not only does it take humans, that takes extreme training and learning, not only how to ask the right question, but how to ask them in the right manner, with the right executive presence, the right communication skills, which you're literally going to have to adopt on the customer. For example, there's 3 personality types. For me, I'm an intuitive type. A lot of visionary people are, like most CEOs. I think of vision, I've got 1,000,001 ideas. When I call Chris, my chief operating officer, who's here, Chris is the voice of reason. Hey, Chris, guess what? Why don't we YouTube live stream 8 hours a day, every day a week, and that way we can talk to the community. And then Chris will call me back and say, nice idea, Mike, but let's think about the practicality of this, the step of the things you have to do to the day. You're already putting in more hours than you can do. How are you going to go do these things? So he's a functional analytical, he's an analytical personality type. And you know what? At some point we need project managers, and they're typically task-oriented project people. So when you're dealing with executives, you're going to get 3 personalities. A visionary guy like me, where you tell me the strategy and I'm happy. You bring numbers to me, I love going good with numbers. I don't know good numbers. Numbers scare me. Oh, what is this charts? I'm a visionary guy. Chris, my chief operating officer, loves numbers. He can literally look at anything, look at these numbers and say, oh my God, Mike, guess what? Because of this and this and this, make the strategic decision. Boy, that's incredible. That's an analytical personality type. And you know what? We've got a PM that we work with. It's an executive that's also functional. And today, when I ask him things, he can plan out step by step. And I've got lots of other people, so you need that. So I don't believe that artificial intelligence can do architecture. How about you, Imran?
Absolutely, absolutely. Artificial intelligence will do what you asked to do. You architect things, and artificial intelligence definitely gathers the data and populate things for you. So definitely.
Exactly. So if you got to get to the CEO to know the strategy and the CIO to know their technology strategy, they're not going to know how to do all this stuff or even how to design this stuff. They don't need to. They need to focus on the business. So you got to translate between those amorphous business goals and the tech that actually does it. So I don't see people going away for that one. Now, the next question is from SI, and it says, hi, Legends. Thank you so much. I appreciate the, honestly, the respect and the decency. You have no idea. We're just trying to help the community. We're very glad to hear from you. What do you think about software-defined networking, network function virtualization related to cloud computing? So I'm going to turn that over to you, Imran.
I think software-defined networking, there are different aspects for different vendors, and software-defined networking is like in terms of software-defined access, software-defined WAN, and as I said, they're just talking about control function and data function, and those controllers, everything is based on the controllers right now, and those controllers can be designed anywhere, as Mike said earlier. Data center and cloud networking is not a much difference. So those controllers, those devices can be deployed and taken care of anywhere in the cloud. I don't see a difference perspective, but of course the longer discussion is required and we have more discussion. But from my perspective, the SD-WAN provider, they have the controllers residing in AWS and somewhere else or on the on-prem. But the key thing is how you routing the function within the cloud, and what we need to reach out to the branches, how your branches will be communicating to the cloud, and what transport you want to take a look. So I don't see much difference. Maybe we take it offline if required for the explanation.
No, I think. Thank you, Imran. I think you really explained that perfectly where it's actually gone. I asked Imran, and the reason I asked Imran is as follows. We all have our areas of expertise. For me, it was BGP, MPLS, IP multicast. And I literally spent 25 years focusing on those 3 things. And then let's talk about, truly tuning your career. So you can become an expert on one thing, or you can become an expert on an industry. So I'm going to tell you what really blew up my career was I was a network engineer, network architect first, then a network architect. And then I was at Cisco and they said, we're interested in focusing on healthcare customers, digital transformation for the healthcare environment. And they decided to build a healthcare team. I was there as a systems engineer slash architect. It was pre-sales. I was the lead architect for the IP voice design for one of the world's largest banks. But I was titled as systems engineer, but I was doing all architecture work, all pre-sales architecture design work. And I heard from Cisco, they wanted to have a healthcare team. So here I was as an engineer, and basically we would be engineer, manager, senior manager, director. And I see this position posted for a director in healthcare. And I was like, wow, that sounds like something I could do. I can practice medicine. I know tech. This sounds fun. I applied for that job. I got it instantly. I moved up 3 levels, at least in job roles, in one move because I had an industry expertise. Now, of course, when I worked at Cisco, they're like, well, you can't change departments and get promoted. So what we have to do is we have to keep you at your current grade, and once a year we'll promote you, which they did. But the point is I became so much better. My career rose like a rocket ship. And why? I had expertise in a certain area. So even when you get to cloud networking, let's face it, if you're an expert in cloud networking for banks, because banks' demands are very different than some other organizations' demands, you can even build an expertise level by being a specialist on a vertical industry. Cloud networking for finance. And let me tell you, the things that we do in finance to minimize latency and optimize performance. I've worked in financial environments, literally speaking, we've got 2 separate racks. In the rack, you have, say, 15 of the biggest, fastest servers in the world. And in between that, you're going to have the fastest switches in the world. And literally, you're going to be all in one rack in order to minimize the latency. Because in some of these financial environments, a nanosecond is a massive competitive advantage. And I want you to really think about this with the current architecture. If I've got a bank, and I can get the information and use an algorithmic thing to produce a trade 1 nanosecond faster, that could be billions of dollars competitive advantage a year. What happens with the stock market? And this is why I say you got to understand the industry and you got to understand the tech to be an architect. So in a financial world, let's say that there's some news, good news or bad news. If there's good news about a company, the stock price goes up. If there's bad news, it shrinks. So what happens if you can literally have a machine learning protocol that can literally follow the news and a second later say, buy the stock or sell the stock a second later than the rest? Why is this an competitive advantage? Why is the architect so helpful here? Well, when stock prices go up, the first person who buys at the cheapest price, the next person buys it higher, the third person buys it higher. So if you can buy it cheaper and you can sell it higher, boy, imagine. And imagine if you're processing a few billion shares per day and you can save 5 cents per share, but you're doing this 4 billion times. That's why you got to understand the business. Could you put that on the network? I would. I mean, in the cloud? Oh, God, no. Why? If it takes you 5 milliseconds to go from point A to point B versus the nanosecond that you're trying to compete, and you can set up a system with 10 million IOPS for a hard drive speed locally, you don't go to the cloud. Look, in the cloud, they've got a cluster placement group, which is kind of the same thing. So what do you do in a bank? You have 2 specialized racks in 2 separate parts in the data center and failover. In the cloud, you've got cluster placement groups. You could do 2. But in the cloud, your cluster placement groups are generally inside the same server. You may need all these bare metal servers without the overhead of hypervisors. So it's all on a case-by-case basis. That's why the machines can't do this. You've got to use that judgment, and this judgment takes a long time to develop.
Just to add another point here, in this SDN kind of a thing, you have more choice of automation and programmability. Those controllers or with enhanced APIs, so automation ecosystem like Puppet, Chef, Ansible, and etc. So they are feature-rich APIs across portfolio, and these are the things that are available in the cloud. With any cloud, you can do the programming APIs from AWS and furthermore.
That makes life so much easier and more efficient. It's no longer the world where you or I, something's not as good as we want. So we telnet Yes, I said telnet, plain text prior to SSH into a router and do a show IP BGP and say, oh, wait, all these routes are in the routing information base. Why aren't they in the forwarding base? Literally going from router to router via show CDP neighbors to try and figure out what existed. That's where Imran and I are from. Imran and I are from a world where customers had stuff and they didn't even know what it was. And we would literally do audits trying to figure out how to design a better architecture by having someone go from hop to hop to hop. And you might have 5,000, 10,000 hops in your system and you're literally going from things to things. And you know what happens in these systems when you check? More stuff is there than you absolutely know. So that's also the security components.
The other thing I'm seeing, in cloud native things, there are a lot of gaps in visibility and tools for networking perspective. And there are new companies are coming in, they're working to fill out the gaps for the main cloud provider. They don't have those features for visibility and control. And they are very successful because there is a literally very shortage of those tools available for perspective or visibility in the cloud and multi-cloud kind of environment. There are multiple companies working inside it, and just to sell us their controllers and their transit gateways to improve their visibility and automation and security piece. And they are purely based on all networks. So
Imran, that's really great information. So what you're talking about is all these other new things that are designed to overcome some of the weaknesses of the cloud.
we are not teaching and something is a single cloud. We're teaching go and beyond for the multi-cloud environment. How do we scale? How do we design the multi-cloud? What are the tools you need to have it? Aside from Wagner's agnostic, we describe in an SD-WAN, there are multiple vendors out there, Cisco, VeloCloud, and other stuff, and same like with the cloud networking there. So we teach you what is the best scale, availability, good use case for your enterprise. Those are live examples with the live calls, with visual drawing for Mike. Mike as well. So I think that's the key differences.
Okay, that's interesting. And thank you, Imran. Let me elaborate a little bit on what Imran's saying here. Imran, when it was describing the way we do our teaching calls, and because we train architects, here's what our weekly teaching calls look like. I literally have an architecture team, which is always going to be there, which are the students. And the students literally, I invite them, and when the students are on our architecture training call, they interview me as they would any other executive. They ask my business goals, my pain points, my challenges, where I'm trying to go. And then I give them a solution. And realistically speaking, when I do my architecture with my students, one day it's 50,000 subnets and 20,000 remote location in place. Another day it's systems that have 100,000 servers. I give my students something that is really, really, really far out there. And the reason I push it to that level is as follows. I want them to know how to do the real job. See, when it's simple, when it's just like add shield and set up a default route, then where you're at, it's nothing. This is literally nothing. I mean, that's not real life. So what Imran was describing is I literally have every one of my students come on calls and they interview me, and then together they collaborate, and then I help design it in real time. You know, we architecturally map it out. And then sometimes the students go build them too. So I like that. Hi, the world is yours. So happy to see you, Smella. Always great to see you here. So let's talk about getting some home practice. Now, in my day, I had 13 routers sitting on my desk, 3 switches, and it sounded literally like a jet engine. Zoom, 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 valves, switches, valves. You know, how do you get practice at home in today's world? Do you need to buy yourself a rack of routers anymore, Imran?
Not at all. Not at all. I used to have running a very large rack in my home when I was doing a CCI. Now everything is virtualized. Everything is virtualized. That's the main advantage, and everything is on one server. Maybe either you get it from us or you make your own server. That's very easy, and you build very large topologies. You can imagine, and you can manipulate and POC at any customer environment, just drag and drop then build your own topology. That's what we are teaching as well, how to make emulate your environment, your customer environment. How do we test it? And it's not, again, whether or not it can be a Juniper, can be Cisco, Palo Alto, checkpoint. You just drag and drop and use those virtualized technology. We can have it's ready, and that is very useful. And the other good thing is when you're testing in a real customer environment, you build this test topology, very nice drawing as well. You copy and paste from your design document, test document, and that is a real implementation plan or migration plan. You can manipulate by learning those technologies. So
Yeah, and I think that's really so great. The ability to design and test something. What are these things? How do they work? They basically take the routing code from the routers. So they're actually running identical copies of your routing software. So while they're creating these logical connections between them, it's the real software. So you get a really, really good test environment. So it used to be that, like, I would do a proof of concept. Here's what it would look like. I go meet with the customer. I found out all their goals. I would do a design. In my design, I would plan everything from point A to point B. Now, this was a theoretical design in our heads, which mostly works. And then we would do the proof of concept, and we would learn, the 10% of the things that we missed along the way. Now, before we even could get to the customer, we can basically test our designs. Customer likes it. I can send it back to my team, a few smart engineers from the team. They can go build this on a simulator, and then they can show the customer that we've tested it on simulations. And if the customer still wants to do a physical proof of concept, we can do it. We can basically rack and stack it to their environment, but we already know it's going to work. We've already got all of our configurations done. We've done everything ahead of time. So now when you prove it to the customer, it's not a 4-month proof of concept. It's get in there, 2 engineers, cut and paste it in, rack and stack them, get out of there, let the customer test it. And in which case, customer test usually involves the customer purchases the product for free. They make an agreement that says, if it works, we'll purchase it. So they can actually test it, and you can be sure that it works. So I remember, and I'm sure Imran was more of this than I was, the concept of validated designs.
absolutely.
So for those of you guys that are new, here's what happened in the world. We had customers that, realistically speaking, started just designing their own stuff. And, Cisco, we had the CCDE, the Cisco Certified Design Expert. The CCIE was also a designer. Even though they were more of a configurer, they had to design it, and then they had to configure things. So they were half architect, half engineer. And then what happened is the customers would have people, they were really smart. Now, I don't want you to think when I say non-networking people aren't smart. These people are brilliant. There are people that literally know 50% of the network, 50% of Linux, 50% of Windows, 50% of scripting, 50% of this. These are highly intelligent people. The problem is they only know 50% of each thing. And if you need somebody that's good to help you build stuff, it's really an asset to have somebody that knows a lot of little things, the jack of all trades. Here's the problem. They can't design something effectively. And here's why. To design something, you need to know everything about how it all works. So focus on something, but you need both kinds of people. You got to figure out from a design perspective. So where we came from an evolution perspective is we had all these really critically smart people, and don't think they're not smart. They are really smart, that started designing these things. Oh, we just need a couple of routers and switches. So they plugged them in. There was no concept of hierarchy. There was no logical IP addressing scheme, and things fell apart. It was fine. There's 10 subnets, everything works. There's 20 subnets, it works. There's 100 subnets, it works. And then you get a hiccup somewhere in your network, and it all breaks, and you can't fix it quickly. And then somehow the customer actually expanded so fast that now they've got 5,000 subnets all on this poor architecture, and it's outage after outage after outage. And then what happens? They call Cisco, and Cisco looks at it and knows it's not their box. So then they point it to the Juniper box, and Juniper looks at it and says, well, it looks like our box is operating efficiently. And then you've got some Huawei device in there. You look at that and it's like, I don't think that's working right. But you call them and it's like, I don't know. And then you mix that with your load balancers from F5, all your systems, and then it all becomes ugly and hard to troubleshoot. So what these organizations did was they came up with the concept of a validated design. And what that would be, we would design things for the customer. We'd take their designs, we would improve them. And then we'd send them to network consulting engineers, people like Imran that were super smart, that could literally look at it and say, nope, 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 fix this. Nope, 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 fix this. Change this, tune this. They'd send it back to us and say, does this work with your architecture still? And we'd collaborate on making it better. And they might even test it for us in certain cases to make sure it would work. And then we'd present it to the customer and we knew it was good. So that's the concept of validated designs. And that's where they came from. How many of them did you do, Imran?
Multiple. I have another very good example for one of the very, very large service provider, and one of their manager goal is they are doing the POC, they are running the equipment for non-Cisco, Cisco, and whenever they go to the field test something, they want to buy the hardware from the Cisco, Juniper, Aruba. So I build a case, how do we save money, build this virtualized environment, and how easy it is for their engineers to test anything and validate the design. So they're very thankful, and I think that design is the virtualized environment is their standard, and they're using it for their in and out and their high touch service company. So without mentioning the name, so
totally with you there. So we've got about 20 minutes left. Imran and I could continue the discussion, or if you've got any questions related to a cloud computing career, a cloud architect career, a cloud networking career, a network architect career, or even a network engineering career, please feel free to ask them. We're here for you. We want to do everything we can to potentially help you build the best career. While we're at it, I have to do the YouTube thing. I've been informed. If you're enjoying this concept, could you please leave a like and or subscribe to the channel? That way we can produce more free content and share it with the world, please. No obligation, obviously, but something that I'm told that I'm supposed to do to try and build a channel. Any questions for the group? And I know there's about a 60-second time delay. So Imran and I are going to give about 30 seconds. If we see some questions, we'll answer it. If not, we'll talk about more fun things from networking. I'm always happy to talk networking.
I'm happy to talk something about your program. The thing I liked it.
What's that, Imran?
I need to talk something about your program, what I liked it, like the most.
Why don't you? So, it's really funny. So one day Imran joins my program, and normally I speak with nearly everyone. And I see it come in, and I'm like, okay. So then I go to his LinkedIn profile, and I'm looking at this LinkedIn profile, and I'm like, Cisco Systems, Juniper Networks, like 2 CCIEs. I'm thinking, I'm getting a little scared. Imran's going to go be my student. Like Imran and me, kind of the same level, same background. Imran told me, he's like, what I wanted from you was this following. I wanted more of this big architecture piece. I wanted more of this executive communication piece. I knew the more executive presence. And when I got it, I went, yes, I got it. So Imran became one of the students in our program. And I think I learned almost as much from him as he learned from me in different ways. And my respect for Imran is so high that I've always had this dream to build a network architecture program, like a good big one. But I was thinking about it, and in order to do this, it's not just architecture teaching like I would do. You got to get into the weeds, some of this stuff. And even somewhere along the line, the networking is so complicated. I mean, it's not to us, but it can be. And you actually have to build some of it in order to truly understand it and design it. And I started to think of, how do we do this? So last week, I bought 3 new 28 core servers with 128 gigs of RAM and some NVMe drives in a RAID environment to basically build a cloud architect network, a cloud network lab that people can do. So, basically that's about almost 100 cores and, and a half and 384 gigs of RAM, because we love this. So, and Imran, when he was trying to say is, he came to my program and all of a sudden we're doing deep architecture, design. And then we're talking about, I'm making the students present them back to me and convince me that they're there. And, then Imran was like, one day I hear him on a call and he's like, Mike, this is all CCDE level stuff. He said, this is architecture. He said, you've described it from the business perspective. You talked about what to teach the CEO. You're teaching the students how to communicate it, write about it, talk about it. And I said, that's the job. I'll let you put that in your own words, Imran, since you brought up the topic.
Absolutely, absolutely. You already described everything, but when I joined the program, that's the key thing I like, the soft skills. Nobody's taught you a soft skill, how to present. And that's most of your consulting job. There are the key things is soft skills, how to present, and you're making a very dumb CEO in front of the students, how to present your business case, how to knock down their questionnaires, and we have a questionnaire, what to ask the questionnaire. So we in Cisco we used to have very long questionnaire when we designed the data center. So you that's the really I really liked it how you put the questionnaire for and just a live questionnaire for that. So I think it's very close and almost very similar with the Cisco CCD kind of a thing. It's very architect, high level kind of program. I was studying when I haven't completed yet, but that is the key thing is to talk to you about this program. I think that's the key difference. There are so many trainings out there, but I haven't seen anybody teaching the way the mic is teaching. That's why I think I'm on the mic and how to build this program in the networking space, the architecting, not the configuring, plus the interview level kind of question, soft skill, presentation skills. That is the go to any consulting job, any technology you can learn, but this is the critical piece.
Thanks for that. I'm going to go back to the soft skills for technology professionals and why it matters and why it should be part of your cloud architect career development program or your network architect career development program. Or anytime you're going to be a cloud architect or a network architect, you're even a cloud architect, network architect. It's so important. See, and I can tell you where I was at. I've spent, or it's been spent with from my employer, at least $250,000 on pretty much emotional intelligence, presentation skills training, soft skills training, and also some tech training. But a lot of it, I did the CCIE on myself. I took a lot of these trainings. Cisco sent me to a lot of them too. But at some point, when I started moving up, it was all presence, presentations, communication, leadership, exercising influence. And I didn't realize how valuable it was. And then I joined one of the teams, and we would advise, the CEO, John Chambers, of the new technologies that were going on. We would also advise customers. We were in a position where we were just trusted advisors. We didn't have a product to sell. I'm not saying we didn't help sell stuff, but we didn't have a product to sell by any stretch of the imagination. We were just there to be consultants. And basically, if the customer wanted to buy something and it presented by the sales team and we didn't think it's a good idea, our job was to say, we don't love this idea. Cisco literally paid us to make sure that our customers were successful, even if it involved killing the sale. That's how much they cared about their customers being successful. And I remember it was my first day on the job. And Cisco had already probably spent $100,000 towards training me to better. I'd been probably about 50 leadership courses they sent me to. And then I went to on the job and I got paired up with my mentor, Francis. Francis was an executive coach. Francis was the chief financial officer of a hospital. Francis was director in this elite team. And my manager said, would you like a mentor? I was like, yes, yeah, I want a mentor. And she said, how about working with Francis? So I got to tell you, here's what my experience was. I came straight out of the engineering team at Cisco, even though I was doing an architecture role. And now I'm in this team. My friend Francis and I were writing a joint paper together. I read it up. I worked real hard on it. I'm really scared. I proofread it. I check it 3 times. I sent it to Francis and she looks at it. And she calls me and spends about 3 hours on the phone with me, teaching me why what I was taught in an MBA program is not acceptable executive writing communication. And she did it in the most delicate way. It had a bigger impact in my career than anything I can imagine. I will be eternally grateful. So much so that I literally called her and spoke to her last Sunday. That's how much I respect her 20 years later. Now, what she taught me, and I first got this job, she then saw me present. And she calls me and she says, Michael, how would you feel if I bought you a few books and sent them over to your house? She's like, because I see some things in your development plan that's going to make you better. Would you be offended by that? Offended? I'd be the most happy, grateful person in the world. And then she sends me this documentation. And one of the books is called Why Business People Speak Like Idiots. And another one is absolutely related to executive writing. I don't remember the name, but it was incredibly helpful. In the Why Business People Speak Like Idiots book, she talked about how when we're taught in MBA programs, we're taught in training programs to speak with this complex language and jargon. And in reality, it's completely meaningless. How to get your concept and your sentences to less than 11 words, how to make sure that it's super readable, how to take the most content and compress it into the period of time. And I remember saying, Frances, why do I need to do this? And she says to me, the reason you don't understand why you're going to need to do this is you've not worked as an executive yet. She said, this team, now that you're on, you're going to be an executive like the rest of us. You're going to find out why you need to do this. So wasn't completely sure, but I knew to follow her. I know that when Frances says something to me, she's one of those people that I just listen and I don't question. So I did her instruction. Then now I'm working as an executive at Cisco. And now here's what happens. I wake up at 6 o'clock in the morning. I'm talking to some people in maybe India, maybe Europe. After I'm done that, I start speaking to the people in the UK. When I'm done that, I typically do my martial arts practice for an hour, yoga practice maybe as well. And then I start working with the people in the US. By 9 a.m., I've already had about 300 emails. My phone's ringing like this. And in between the phone ringing, I get a phone call that says, can you be in Dubai tomorrow? I'm like, 2 o'clock in the afternoon. Yeah, but can you be there tomorrow? I'm like, I don't think I can get there that fast with the time zone, but I can be there the next. Okay, you go to Dubai. What's the presentation on? Don't know yet. Oh, okay. You want me to go to Dubai to speak to someone in Dubai Internet City and we don't know what the presentation is? Yeah. It could be on this, or this. We'll let you know when we get there. And then I started to say, oh my God, you can't possibly read complicated materials when you're being interrupted like this. And then I started this organization and I went, wow, this is going to be fun. I had no idea that was going to occur, as I literally get 1,000 emails plus Slack messages plus text messages every single day, plus at least 150 phone calls. So if you can't send it to me in 3 seconds or less and I can't read it, I'm just not going to read it. And that's why those things that Frances taught me were so invaluable. So when you're going from engineering to architecture, you must learn these exact business communication skills. There's no way around it. So how have you been doing on the executive communication skills and executive writing? You feel like you've learned a lot?
Absolutely. That is the nutshell of our program. Not only the technology, the executive summary and the softer skills that Mike just described and the interview. So that is the one of the best part of the program.
So there's 2 more questions. We'll answer these. I'm going to answer the Gopal one because it's probably the easiest to answer, and then I'm going to spend some more time with Mark Simpson's question. Gopal says, hi, Mike and Imran, any advice for a young generation without core experience, implementation of the network, or just having knowledge of the network? I will tell you what I did, and then Imran's also coaching younger people, so I'll ask, how he's done it. I worked with a lot of people while they were in high school and college, and here's what I did. I'd typically start, with the CCNA. And the reason I started with the CCNA, it was kind of like an intro to stuff. And, what I did is I'd have the person read the official Cisco press books. No Udemy, official Cisco press books. They put more detail. Why am I saying don't take these Udemy kind of courses? One of the most major training vendors asked me to make a CCIE course for them. And I said, tell me more. They said, you need to put it inside of 4 hours. And I said, wait, you want me to make a 4-hour CCIE course? And they said, yeah, can you do it? I said, no one can do this. I said, I read 75,000 pages of reading to be a CCIE. You want me to put all 75,000 pages and 2,000 hours of practice time inside of 4 hours? And they said, of course. And I went, nope, not doing it. But when you read these Cisco press books, they're deep. They're written by Cisco people. They're written by knowledge. So I would say, do that. Then I would say, assuming you've got very limited resources, by yourself. There's a GNU3, which is a Cisco router simulator you can use. You can do practice jobs on those. The reason I said GNU3, I think that's the name of it, is you can get it.
GNS3, yeah.
GNS3, thank you. You can get it from the on Ubuntu Linux. You can get it for Windows. It's simple, it's basic, and it's free. And on these things, with this, you can do a relatively good network practice. I used to use it with my students. You can do the Cisco things. Then you can take our free stuff. We've got a free AWS Advanced Networking course, which is basically, introduction to networking. And then you can try and build some of these things we talked about in the cloud. Now, Gopal, if you're looking for something much more deep and you're looking to basically kick off a great career with, starting point of basically introductory level, and you want to be to the level where you can get these big jobs, for that, we have our Cloud Architect Career Development Program, as well as the Network Architect Career Development Program that's going to be coming out real soon from Imran and I. And what we do here is in these programs, we literally teach people the foundation first, and we focus on big, deep fundamentals. And why so much? Because when you understand the fundamentals, we can build fast. And if you've got a good fundamentals, and we spend 2 to 3 weeks building a really strong foundation, then we can progress like a rocket ship because you understand it. And guess what? The advanced things are just new iterations of the fundamentals. So when I coach people, cloud, network, and I see them, they started off with an AWS certification, for example, or just a CCNA without reading the book, taking a course. They know the names of the things and how to configure them, but they don't know what to do. So my perspective is read the Cisco material or take our training, because we get deep, and keep your training limited to people from Cisco or Juniper Networks, or maybe Arista Networks, or I'm not a big, or even Huawei Networks. Get their documentation, which is usually Cisco's documentation. Read that and make sure you get it from the source. We are the source. Both Imran and I are from Cisco. He's also from Juniper. I also worked at Riverstone. I'm a big competitor to Cisco. So we have been working for the service providers and designing these systems for a year. So I would say get people that have come a big, long storied background from one of the Cisco people or Juniper people. Why? Because we dealt with everybody else's mistakes for the last few years. We've basically met with every executive in every organization. We've designed systems. I've probably touched, 4,000 or 5,000 networks in my career. I'm sure Imran's done more than that. So, there's that. So any last minute advice for Gopal before we get to Mark? Imran?
Yeah, I used the same thing, Mike. I mentor a lot of people in the community, non-community in my career, and start from the CCNA level. Absolutely, fully agree with you. Most of my thing, do the CCNA, do this reading, and take the exam and practice with other GNS, viral, EVNG, and I think we will demo this next time in our live demo lecture. What kind of topology you can create? Yes or no? So yeah, go ahead.
Imran. Guess what? How do you want to do a live demo with me in the next 2 weeks?
Absolutely.
Okay, everyone on this call, we are going to do a live demo of a network simulator software, Imran and I, coming in the next few weeks. So I want you guys to all see it. That question is there. By that point, we're going to be closer to having our network architecture thing released, but we want you to understand how to do it. So Imran and I'll do it, meaning Imran will do the demo. I will talk about the architecture piece. We'll do it together. That way we can leverage each one of our experiences. Thank you so much, Fortuna. Leo, we're thrilled to do it. Now, Mark Simpson asked a question. What effect did microservices have on the computing environment? So I'm more on the infrastructure side, but I still deal with microservices all the time. My perspective and the clients that I work with are a little bit different. I typically work with organizations that need massive computing power, massively fast networks. And I'm still dealing with a lot of people that are still dealing with bare metal servers even, because once you add a hypervisor, you lose about 10% performance. Your disk performance goes away as well. So I'm still dealing with people that are working on bare metal servers for my elite clients that I'm dealing with. I'm also dealing with people that are using VMware and Docker and Kubernetes containers. And I think, a lot of those are the future. So as an architecture perspective, again, it's on a case-by-case basis, but I do see microservices becoming more popular. Here's where I kind of see the evolution of the world, then I want Imran's take on this. When I look at it, I first see big compute or big network, which gets into virtualized compute into network, which gets into the next level of virtualization, which comes in the next level of automation and virtualization, et cetera. So for the DevOps people that are out there, that are literally doing these wonderful automated software release cycles, doing some of this infrastructure as code things, doing some incredibly wonderful things. I absolutely love it. But I see these kind of things that are going on from a lot of places, a lot of where, and I see a lot more movement to DevOps. Now, DevOps is not architecture. They're extremely different career. Architecture is design. DevOps is kind of this build, automated release. But I seem to think we're going to have a lot more containerized services in the future because it's the next evolution of virtualization. How about you, Imran?
Absolutely, 100% agree with you what you described, Mike. Absolutely.
So, Mark, I see it headed there. Mohammed, you got old Cisco syllabus and Juniper background, but you really need a step-by-step. That would be enough. Yeah, we're going to produce the step-by-step, Imran and I, and it's coming. So if you're not a member, please subscribe to the channel. While you're waiting, you can do the AWS Advanced Networking course, which is completely free. If you have any interest in cloud, you can do our completely free AWS Certified Solutions Architect Associate. Guess what? There's a completely free companion ebook. The links are going to be in the description below. You can do our AWS Advanced Certified Solution Architect Professional. We do it more from an architecture perspective than an engineering perspective, and the AWS Advanced Networking. Do that stuff, and you're going to have some relatively good fundamentals in cloud and cloud architecture. And then, if you really want to learn how to be a cloud architect, we'll take those fundamentals, and then we'll build deep, deep, deep knowledge. Typically speaking, we layer on at least 250 hours of training, live, interactive, group training to take people that are certified and make them really great. That's kind of, our process. And our process is going to be as follows: communication skills, presentation skills, interview skills, negotiation skills, executive presence skills, empathy skills, executive understanding, CXO relevancy, and then tech, and some more tech. And when we get into tech, it's going to be deep tech because we need people to know how to interact with the client. You can't just deal with a small client. You've got to be able to deal with a client that's basically spending $300 to $400 million a year on their IP budget. Amram has done many billion-dollar designs. I've done many billion-dollar designs. So I just want you to understand that's where things are coming from. They're coming from, you build the foundation, and when your foundations go, we escalate. If you don't have a foundation, like yesterday, someone said, how do I learn the names of the AWS services? I said, you're asking the wrong question. You need to know, what are you trying to achieve? What's the goal? Is the goal to move it to the cloud? What's equivalent on the cloud? Is the goal to refactor on the cloud? What's the cloud? I can't tell you what to do or learn or what to do in a project until you know the absolute business requirements. I'm going to close it on this. Imran has probably bought 15 or 20 routers in his house and servers because it's cool, because he loves it. I know he has. I know Imran. And if you walk through my house, you will see 8 servers. My personal desktop has 16 cores and 192 gigs of RAM. I've got big enterprise-grade Meraki firewalls, and as well as Meraki switches with 48 ports running throughout my entire house, wired with 10 gigabit Ethernet. This is not normal. People don't do this. I buy tech because it's fun. Businesses buy tech to transform their businesses. So you want to be an architect, you must understand that business thing. They're not geeks like us. They don't want to say, oh, cool, the new iPhone came out. My iPhone's 3 months old, but I got to go trade this in and buy a new one. I want a new one. That's not how businesses operate. What technology enables their business to grow, be agile, improve their business, improve their service delivery, improve their relationships with customers. That's all that matters. Technology comes second. Any last minute closing things from you, Imran?
Absolutely, Mike. Just want to add here, with this kind of 20 or 20 plus year experience working with the industry, with the technology, business equipment with Mike will make people architect, rather what technology use, a network architect and cloud architect. So we are here to make you on the next level. That's my true point, and we met a lot of people already in the field, and we have tons of students that are coming and signing up. So sign up for any free courses, reach out to us for any question and concern, and we will have a more live demo with a very large scale topology showing to you. So over to you, Mike.
Thank you so much. I'd like to thank you all for participating. You know what? Both Imran and I have an incredible number of connections inside of the tech industry. If you guys would like, and comment below, if you'd like the concept of having more conversations with industry experts to talk about strategy in technology. I've got friends that are running the elite conferencing things that are cloud-based. I've got friends that are in all the security environments. I've got friends that work for all the cloud providers. If you'd like us to have more experts speak with an expert session, let me know by typing expert sessions in the comments section below. I'm going to answer Jason's last key. When you start the course, are you joining with everyone or doing the course? Or are you grouped similar with people starting a course? So Jason, the way we run our courses is as follows. Typically speaking, with our courses, we do live training twice per week. And the reason we do live training twice per week is we don't believe in our hearts that video on demand training is enough. So typically speaking, we do live architecture training sessions twice per week in our training programs. Now, when we do this, we kind of do this as immersion therapy. What do I mean by immersion therapy? If you're a new architect or you're an old architect, you're new in our program and older, the architecture designs are similar. So what we typically do is we invite everybody to the same architecture sessions. If they've been with us for a week or 6 weeks, it doesn't matter. And in the beginning, the senior people become the lead architects for these things, and the junior people learn and ask questions. And then what ultimately happens is 6 months, like 6 weeks later, then the senior architects graduate and they're working. And then the more junior people who've been mentored in this entire class and watching, then get to come and kick in and they're good. Now, in between live sessions, like what we do is we have videos. So the students do things individual, like in our cloud architect career development program, which is how you become a cloud architect. And we've got a great success rate with helping people find jobs when you're done. You basically do your live sessions, and in between classes here, what do? You do projects. And in between the projects, you turn in the projects for us. And when you turn in the projects, after you've done that, we grade them. We give you feedback. Yes, it's right. No, tune this. And then we do this throughout the program. So in our training programs, they all have a minimum of 250 hours of training. This is not just something, these are architecture programs. We'll have students do practice presentations. They submit them. We give them feedback on it. Practice designs, they submit them. So that's the way we train our people. So Jason T, I hope I answered your question. Imran, I've got to thank you for being part of this session. I'm really excited about building some network architecture training with you. It's very rare that I get to find someone that has your level of skill. And when I saw it, I knew we had to do something with it. Like, I've been doing networking forever. I've consulted to everyone, but I wanted to make sure that we had the best. So you've got 2 CCIEs, you're finishing your 3rd CCIE right now. You've got about 25 years of experience. My CCIE number is 7417, everyone. Back when it was a 2-day miserable exam with like a 98% failure rate. We've been in networking forever. Of course, I teach networking, but Imran's been focusing more on the ground networking. I've been focusing much more at the CEO strategy, and combine this, you marry the 2 skills, CEO relevance, executive communication skills, combined with those deep technical skills that Imran has. I think we're going to give you a program that's going to change your lives. And we're going to do it at a lower cost than anybody else that's ever doing something of equal quality in the world, like we do everything. Here's the thing for me. I've got students in Pakistan. I've got students in India. I've got students in Africa. I've got students in Asia. I've got students in South America, Central America, Mexico, Canada, the US, and pretty much every place you can possibly imagine. And because of that, not everyone can afford US rates. So we work really hard to use the best technology in the world that we can. And we even built our own clouds, that we run everything from our own clouds, because we can do it for about 1/5 of the price of the cloud provider, because we're experts in data centers. And we do this, and then we can do it. So stay tuned. The Network Architect one's coming soon. But if you have any interest in our Cloud Architect Career Development program, and trust me, we'll take you from there, and you will learn a lot of networking in our Cloud Architect Career Development program, almost to the CCNP level, Cisco Certified Network Professional. Every one of our students in our cloud computing session gets that. So any questions, you can do that. Now, if you've got any questions about our training programs, you can also call us. I'll drop our company phone number here. And I'm going to bring in some other networks, and they're going to be coming from other companies that are not ours. You guys want it? I have the connections. We'll make sure we get you some people from the security world. We'll make sure we get you some people from more networking perspectives. We're going to get you some more cloud people. We're going to get you people from all over the world, maybe some IP video people, some voice over IP people, some conferencing people. We want to expose you to the best. So it's coming. Look forward to seeing you there.
One last thing, Mike, and just to add here, there are a lot of hiring managers coming to our call as well from Amazon and other companies. So just to add here, And thank you, Mike, to be part of your team. I really thank you for your kind words, and thank you for all who are listening. This thing, stay tuned. We'll get you there, what's need to be there. So we are here to help. Absolutely. Thank you,
Thank
Mike.
you for that. And I don't even talk about that, hiring managers from companies that sometimes attend our calls. Recruiters contact me every day for our students. So thank you for that, Imran. Everyone, it was so nice to speak to you today. Love having these interactive sessions. If you have the ability to like this, good. If you found this was useful, please forward the video to others that you think would be helpful, because we want to do everything we can for the cloud architect and the network architect community. Thank you, Imran. Thank you, everyone. I look forward to speaking to you all really soon. Take care, everybody.
Bye. Bye.